Okay, let's just get started without a camera. You don't need to see me anyway. I kind of don't look great today anyway. I'm also a little, like, I feel like I'm getting a little sick. So, like, uh, I'll, I will, let you know if that becomes a problem. Okay, yeah, so, like, the problem would be that, the part that I'm getting sick in is my throat. Um, Today, we're talking about more stuff with tables, more stuff with, we're going to get kind of a bit deeper into how loops work in Lua, and then, like, do some math. And, like, you know, basically finish out what we've been working on. I'll give a few ideas for, like, ways that we can improve upon it at the end. I should have actually made another slide for that, but that's fine. So, where we're starting, I'm going to move this like here so I can see chat. Is we are so far we have, if you'll recall, this little pal who can move around and stuff, but there's not really much going on here. So what we're gonna do is we're gonna do, you know, like I take, you know, what a game is, quote unquote, to be very broad, but you know, we could probably do more here to make it more game like, right? So what sort of the trajectory that I have in mind for this game is that it is basically going to be a game where there's a bunch of stuff on the screen and you got to collect it. So this brings up some interesting ideas about, like, you know, mechanics that we can start playing with. Like, we'll need to know things like how to make more than one thing appear on the screen. That's usually useful for making video games. We're going to need to talk about how to think about, you know, where things are in relation to each other. We're not going to do, like, real complete collision detection. That'll be next time, or for our next game, just because I figured that was too much to cram in here. But we are going to do some math to track, like, distance and stuff like that. So the first thing that I would say that we should probably do is to make another object, right? Something else. I said last time, one second, going to do that. You know, I'm calling them coins, but, like, then I said that maybe bones would be better because I am me. We're going to basically make a bunch of stuff on the screen that we're going to pick up, and in order to do that, we need to start a new table. This is going to be, like, you know, if we wanted to do this, like, just to start out, first, let's say we sat down and we said, okay, we want to make a new object. Our first instinct might be to do something like, you know, coin dot, like, coin equals, kind of do it the same way, right? And, like, coin dot x equals 100, and, you know, so on and so forth. But then, like, you know, we run into this problem where we will now need to make a whole bunch of these, and we need to name them different things each time and stuff like that. So probably a more efficient way, and, like, I would say that this way that I just described is aggressively inefficient, right? Is just basically make, like, a table that wraps all of our new objects. So yeah, let's call them bones, because I want to. You're a bone collector. So we got this table. The table doesn't do anything yet, right? Where are you? You are here. Okay. Just checking in on chat. So now we're going to make our first like custom function. And this function is going to be used to make our bones and to put them on the field. So we're just going to, as we described in our previous couple lectures, we're going to make a function, just varying the word function, and then create bones. That's just what I'm calling it. You can call it whatever you want. You can call it make bones. You can call it, you know, it's fine. But like then we would need to remember exactly what that word is. So I like to make function names just descriptive. You should get into the habit of making function names as descriptive as you can. So I'm going to call it create bones. And put an end tag, so then all of our stuff goes inside between the where we say function and between that and end. So inside of this, excuse me, inside of this function, we're actually going to make a new table. So when we run this function, what we're going to do is first we're going to make a new table, and then we're going to add that table to our other table, to this one. So this one, as you notice, is plural, right? This is going to be the wrapper for all of them. But we still need basically something like this. So sort of what I described at the top of class, or whatever I'm calling these. It's weird to say class in this context, but you know what I mean. It is a class, I guess. So we're going to make a new table called bone, and then bone.h equals, I'll make it 10. You can make it whatever. This is just like the height of the width. Bone.w equals 10. And we can make these like, you know, longer or whatever if we wanted to. I'm just gonna make them squares. I'm doing a height and width first. One second, sorry, I got something stuck in my tooth because I want to reference them in a moment. So it's really weird, like pausing and stuff like that when you can't see me, I feel, but that's fine. Yeah, I am making bones today. I'm always making bones. I got someone in a meeting that I was in yesterday commented to like the gear that's behind me, like a lot of it's audio equipment, but I do just have some bones behind me because I made that game last year that was like involved bones and throwing bones. And then, so the reason why I did the height and the width first is because I want to reference the height and the width in the next statements where we're positioning them. So we're going to say coin.x equals, and then we're going to write math.random, and that just, you know, as you might imagine, generates a random number. The number that we want to generate for our x value is going to be, I'm going to comment this out for a moment, just so I could pull this up. It's going to be, we want it to be somewhere between here and here, right? The 0 and the width of the screen. But we don't want it to like overflow, right? Because remember that rectangles, which we're going to make, these are drawn from the upper right hand corner. So that means that like if we put it over here and we didn't account for the width of our rectangle, it would potentially appear off the screen, which we don't want. So we're just going to write math.random. Then, so the random function takes two values. It takes a minimum and a maximum. And for our minimum, we're just going to write 0. For our maximum, we're going to write love.graphics.getWidth minus coin.w. So as you see, I'm doing bones. I have coins in my notes, so bone.x and then bone. And then same thing over here for y, but for height. Bone.y equals math.random 0, then love.graphics.get height minus bone.h. So all this is doing is like accounting for, if it rolled like the height of the screen or whatever, it would subtract the amount that the bone is tall, basically. And if we did these, like, usually I do x, y, width, height, or height, width. If we did these, like here, then it would, once it saw this, it would look above, basically, and say, like, I don't know what that is. You haven't told me what bone.w is. So we have to put these below, where we define what bone.w and bone.h are. Cool. So now what this does is creates a new bone. But like if we ran this function a bunch of times, it would basically replace this over and over again. And we want to save the new bones that we make to our bones table, right? This one. So the way that we do this in Love, or in Lua, but Love also, is pretty simple and pretty straightforward. It's this function called table.insert. And this is another one that is just built into the language. And it takes two parameters. It takes the first one is bones. It's the table that we're inserting the thing into. And then comma whatever it is that we're inserting. So that basically means we're taking this and putting it here, right? Sorry, I'm just getting caught up with chat. You do need to declare it. I'm pretty sure. Can you give an example of like sort of like what specifically you're talking about, just to make sure that I'm getting it right? And hi, Proximal Bog. How are you? You want to talk about music or something? I guess DM me. Right now, I'm not in that mode, but we could talk about that off mic if you want. So at this point, we could just like run this function, and it will do that, right? So it makes sense to just basically stick this in load, because we won't, that's the only point that we need to run it for this game. So we have to put it under where we declare our initial table, right? And then we can just say create bones. And so now it's going to, as you might imagine, just make one, because we didn't tell it to make more than one here. Did I not save it? Well,
I can.
Nope. Don't want that. Oh right, I am silly. I didn't do it in draw. I didn't give it in graphics. Like I said, I'm a little phasey today, but it's fine. So the way that we draw it is the same way that we draw anything. And here's a good enough time as any to talk about how we do loops in Lua. 1 second. Sorry, I'm just reading your comment. Yeah, you can just like write bone.w, bone.h, etc. Once it exists. So the way that we're going to draw anything, or the way that we're going to draw our bones to the screen, is using what's called a loop, right? Those of you who have programmed before probably know what loops are, but the way that Lua does it is like a little interesting because of how like tied to existing in tables and operating on tables loops are often in Lua. So we have like basically two kinds of loops in most programming languages, like two broad kinds of loops. I know people who are programmers will probably like be mad at me for that analysis, but usually like they're what are called while loops, which means like while something is happening, do the thing constantly. So like something like update, for instance, is kind of like a while loop, right? As soon as the program turns on, everything inside of here just keeps on going forever. Then there are a different kind of loop called a for loop, which generally is like if you have something that you want to do a certain amount of times, then you would use a for loop. There are other kinds of loops in different programming languages. Those are the two that we're going to be concerned with. But the way that Lua handles for loops is very interesting, I think, because of as I said, like its proximity to the table structure. Like usually you'll see loops, for loops especially, used to operate on arrays and other kinds of data structures. Variables where that hold a lot of variables. So you might say like I want to look at every item in a given data structure and operate on a specific one. And for loops in Lua kind of have that built into them. So they're kind of similar to like for each loops in C# if you're familiar with those. They don't have to be, but again, like everything in Lua can kind of serve a bunch of different purposes with just a few small tweaks to the syntax. The way that we're mostly going to be using them is like this. So we're going to say for I and comma v, and I'll just stop and explain sort of like what each of these means. So this means that we're starting a loop, right? We're starting a for loop, and we're then declaring a temporary variable. So this I is only going to exist for the time the loop like happens, and once the loop finishes, I is destroyed basically. We never have to worry about it again. But this is basically keeping track of the amount of times that we've been through the loop. So like the first time we start it, it's going to be presumably 0. And then next time it's going to be 1, next time it's going to be 2, etc. The V, on the other hand, is because we're going to be like using this to look at each different item inside of our table. The V is going to be the current item that we're looking at. So this will allow us to just like quickly do things to whatever, or look at the specific item that we're looking at. So then we type this thing called iPairs, which just is the kind of structure basically that the table is, or rather it's in iPairs. So we're going for times in the amount of times that the amount of items that are in the structure bones. Then we're just gonna say do, and that just means start the thing, and then end. So here we can say love.graphics.setColor, and I'm just gonna do white. We could make it like an off-white if we wanted to, but you know, I'm not gonna get too weird about colors right now. And then love.graphics.fill, or sorry, love.graphics.rectangle. And then this is fill. And then we're going to just, oops. This is where this comes in handy. We can just say v dot that. And so this means whatever the current bone that we're looking at is. So I hope that makes sense. If it doesn't, let me know, or DM me or whatever. Just to reiterate all the little bits of it, this means for I, where I is the amount of items in bones, set the color to white. We could just do that ahead of time also if we wanted to, but I'm doing it inside of this loop. And then draw a rectangle where the XY width and height is whatever the current XY width and height of the current bone that we're looking at is. So if we run this, we got a bone. Forget if the random seed gets updated. I guess it doesn't. We could update that manually. You can look at how to update that manually. We got a lot more to get through today. So that's fine. Now let's create a bunch of them. So like the simplest way to do it probably is like just running this function a bunch of times, right? We could like also write that into the function as well. You know, it's two ways to do basically the same thing. So here's another way to write a for loop, because we don't have to do it so that it's like looking at inside of a data structure. We could just say like run this code a certain amount of times. So we could say like for I equals 1, and then comma 10 do. And now this is just going to start at 1, go to 10, and do this that many times. So now we got a bunch of bones. And like I said, we could also do that like, okay. We could say like here for I equals, or whatever. I'm going to do it up there just because I want to. Yeah, language. This was an ill thought out thing for my thing that I want to be PG at most. I just think that the term bone collector is a cool phrase. That's all. Why is my computer wanting to be slow? All right, cool. So now let's do a little bit of math, because math is fun. So, like I said, we're not going to worry about like real collision detection this time around, but we can still kind of like fake it. And the way that we can kind of fake it is by like calculating distance. So this is going to get a little weird and a little bit imprecise, obviously, because of we can account for some of the weirdness, but not all of it. For instance, we're basically going to be calculating distance from the upper left-hand corner of this rectangle and the upper left-hand corner of any other rectangles that's nearby. And like once it's within a certain range, then we're going to destroy that. Destroy the other one, right? So like the simplest way to do this is like with the distance formula that you probably learned in math class. So let's just write a new function. And again, this is kind of an inversion kind of the Pythagorean theorem used to find the distance between 2 points. We're just gonna call it distance. And how are we doing? God, every time I go back and check on chat, it's worse. Thanks, Nolan. I also just saw Phoenix up top saying, "I love lying," and same. So we're gonna give it two pairs of points. Basically, we're gonna give it. I'm just gonna type this here. We want x1, y1, x2, and y2. So this is gonna be x1 and y1. Here, I'm gonna comment this out so that we can look at this. X1 and y1 is gonna be this point. X2 and y2 is gonna be the point of anyone that were nearby. And we're gonna talk about how to do that in a moment. So we're going to just write these as arguments. So as we recall, an argument is just a... I realize I also didn't update the this. That's fine. Here, I'm going to just do that quickly now. Should be science and technology, I guess, for game development. Education. I do a bunch of things. Lies are fun to do with friends. Yep. So, as we recall, arguments are just things that functions can have that will change between when we call different instances of the function, or not instances, whatever, like different times we call the function. The arguments will change. And then end. And now, to make this work, we're going to use a different keyword that we haven't used before. So we're going to write this word that says return. And all this basically means is if the function outputs something, if you're going to have a value at the end of it, you're going to return something. So I'll show you what this looks like in practice in a moment. So we're going to check the square root of, oops. If you wouldn't, that would be cool. Of y2 minus y1 squared plus x2 minus x1 squared. So now, like, what this allows us to do, since we're returning a value, is that we could just write like, if we had a variable called like, I don't know, distance to point or whatever, equals distance. We could like write it like that, where we use just this as basically a value. Once we fill in this, it'll just do the calculation, and then this will be that value basically, and then we could save that to a variable or do whatever else we could do with just a number, you know. And that, you know, is very useful for a lot of stuff. So now we have this distance formula. So what do we do with it? Sorry, my like back of my ear just like popped. What I would do, what I'm going to do, is go into our update function. Just make sure that that's update. And now we're going to write another for loop because we want to check to see. Basically, what we're going to do is we're going to every frame check through all of these and see if this is close to it. So if we're like here or something, and we check through all of these, check to see if this one is close to that, which it will check to see if that one's close to that because this is in our table. It'll say yes, I am close to our collector, and then destroy it basically. Just kind of too excited to be up for destruction, but that's fine. So we're gonna say for same thing for I comma v in y in I pairs bones do end. I always like to write my end after I do the first bit just so I don't forget it, and it's easier to keep track of. And then we're going to say if distance, again we could just kind of use this as a number, player.x player.y v.x v.y. So remember, v just refers to whatever the current item we're examining is. It's less than or equal to, I'm just gonna say player dot w divided by 2. So like half the width of the player away. Then end, and we're just going to say table dot remove, and then again I have it written in my notes as coins, so I apologize. Bones, because that's the table that we're looking in, right? And then I, because that's the item number. This one needs a number and not like an object or whatever this actually like refers to, right? So yeah, let's see this working. What did I do? Did I misspell something? No, that seems fine. Live coding, folks. Enough. God, I'm so mad. Every time I go back to chat, I'm like, I get more and more angry. So yeah, what's your problem again? Okay. Attempt to call global distance a number value. called this player, right? Yeah. This is annoying and frustrating. Probably should have tested my code beforehand. Oh, do I have a value name distance and a function name distance? That's entirely possible. Oh, yeah, duh. I do entirely do that. So let's just call this dist. Yeah, this is what happens when we try to teach on like 2 little hours of sleep and being sick. Not an excuse, but you know. So here we go. So now we're collecting these boys. And like I said, this could definitely be improved. But you know, it illustrates sort of how functions and math like this can work. So the next thing that I think would be worth doing is quickly like coming up with some kind of thank you, Nolan. Like basically a way of keeping track of game state, right? So like when we're talking about video games, a lot of time this idea of state, like in games generally, like you know you hear discussions of state a lot, and in video games specifically, there's like I don't want to say like 2 kinds of state, but like there are the game has a state, right? But also different objects within a game have state, so like it can get a little confusing. I'm just talking about like the state of the game. Like, is the game running? Is the game have we lost? Have we won? Etc. And I'm probably not gonna like go through all of it because it's a little monotonous, and like you'll probably get it after the first like bit of me typing out like what this looks like. But let's make another table for this. So like there's this idea in programming, a pattern, a quote-unquote design pattern that you might see tossed around sometimes called a finite state machine, which basically means that like there is a way that the thing that we're looking at is like you know, is an enemy aware of your presence? If not, then it is like maybe in an idle state or something like that. But once it is, it's in like an aggressive state or whatever. We're kind of going to make like a very, very tiny one for the entire game, right? So like, is the game being played? Is the game, have we won, have we lost? Like that seems like fine. So I'm going to make a new table, and we call it states. And I'm gonna give it, like I said, 3 states. States.playing. I'm just gonna make them numbers. Like that's you often see states represented with what's called an enum or something similar, which is basically just a way of making like words numbers, kind of, or vice versa, like giving a label to different numeric values. We're not gonna like worry about UI or anything like that this time, but states equal wins 2 and states dot lose is 3. That's fine. God, it just keeps on getting worse every time I look at chat. Oh my god. Thank you so much, Nolan. So, yeah, it's super bare bones though, like pun entirely not intended. But it'll be fine for our purposes. So like, you know, we could just, you know, do something like you know, if playing, or sorry, states dot playing equals or if here, gonna go back, do one more thing. I'm going to say cur state equals, or you could just say states dot playing. And then we can say like if cur state equals states dot playing. We could make like a start state or whatever, like if we wanted a main menu or something like that. And then just basically wrap the whole thing in that. I'm just gonna grab all of this. And then I'm just going to I'm gonna what? One second, I'm gonna check chat. That's what I'm gonna do. And then I'm going to like one thing that we don't have yet, which would be useful to have for this game, is any kind of semblance of score. Any place where we can keep track of, like, you know, how many bones we've collected or whatever. So I'm gonna just write a variable up here. We're just gonna call it score. 0. I'm keeping a tally in my head of, like, you know, ways that we can make this improved, right? And 1 is going to be like, you know, make a function that resets the board, which, you know, that's a bit tedious. It's not like hard, but it is like, you know, I'd rather show you new concepts that you haven't yet seen. Those of you who are new to this kind of programming, especially. Okay, get rid of this. So every time we collect a bone, realize we could, like, our character could just be a dog or something like that too. We're going to say score equals score plus 1. And I think we can like be fine to draw the score up in the corner or something like that. So oops. Graphics.setColor. We're just going to make it white, because why not? You can make it whatever color you want to. Technically got like 9 minutes left, but might go a bit over because I stalled a bit in the beginning futzing around with my camera. So then we're going to say love.graphics.print. Oops. Score. Then. Where do we want to put it? Actually, you know what? I'm going to do printf. And then we could say, like, if we want to, score colon, so that people know what the number represents. And to stick, like, words and numbers together, so, like, if we wanted to, like, you know, say I don't know, if we wanted to have multiple strings, for instance, like is or whatever, we would have to stick them together with with 2 dots. That's called concatenating strings. But you can also stick a variable onto this. So we could say score dot dot, and then score, just the score variable that we have, and then like, you know, wherever we want it to be. And then when we run it, love some errors. Where were you? 27. Okay. Wrote then. Oh. Don't forget your 2 equals. Just like to hammer that home, if we use 1 equals, like here, this is setting this to this. It's saying this equals this. 2 equals checks equivalence. So if cur state is equal to this. So we're not setting this to this here. We're checking to see if this and this are the same. This and this. So yeah, important and easy mistake to make. I make it all the time. So now, as you can see, the little score up in the corner is getting bigger. We still don't have a way to lose though, right? So let's build that in real fast. Or at least like some kind of time limit. And then we could do like the rest of the state machine. So for games like this, something that I like to do is just have a timer, right? Because that's pretty easy. So if we could write time equals 15. That seems like too little, but that's fine. So back and update. We're just going to say I'm going to explain what this does in a moment. If, as we've seen a bunch of times before, time is greater than 0. So that means if we haven't hit 0 yet, then and for right now we're just going to say end, but we might make this branch in a bit. We're going to say time equals time minus dt. So this is just going to subtract the time since the last frame, and it's going to keep on ticking down. And we could round this down also, so that there aren't any decimals, because this is going to be like a nightmare decimal if we print it to the screen now. Let me just show you that quickly. Graphics. Printf time time 50 which one's Y? This one, right? Is that fine? I don't know. A very bad sense of like intuitively where things go on a screen. Yeah. So like as you see, this is not quite what we want, right? So a way that we can fix this is let me just pull up to make sure I get the syntax right. Love2d.org. Gonna go over to the documentation. I'll I'll put it on where you can see it, so that y'all can see what I'm doing. This is relevant to your lives. So yeah, if we go over to Wiki, that's basically the documentation. I think it's under math. It's not called floor. Does this not have, I was certain that there was a way to round. There's something else. When in doubt, just go to Google. 2D rounding. Yeah, it is math.floor. Weird that it doesn't have it there. So yeah, we could just do one of these. Maybe seal would be better. So this just means like round up. Yeah. So there we go. Got a nice, not horrible number. So now, what we could do is we could say like, okay, but actually, why is my computer being so slow? It's fine. Yeah, I would love to make this like Dark Souls. Yeah, beat Dark Souls in 10 seconds. So where what was I doing? So So now we could say like, you know, time is less than or equal to 0, then current state equals game over, or rather states dot game over. And yeah, so like right now, all that we'll do is just, you know, once it hits 0, it'll make it so that you can't move anymore. Yeah, I forget why it prints -0. I think that's like a weird bug with the engine or something like that. Or maybe it's just a weird bug with my math. But like we can make it so that now we just don't draw anything once we hit game over, right? So yeah, like all of this, let's say, we say if cur state equals states dot playing, then do this. Otherwise, don't. So now it's just gonna tick down and oop, it's gone. So this is a video game, right? I mean, like, whatever, anything's a video game, but like, this is closer than we have been so far to having a video game. What I would suggest for, like, you know, modes of improvement, right, is like, we've already done a bit of printing, but it'd be nice to have like a press any key to play. Like, maybe I would, if, you know, I was doing this for real, or, you know, quote unquote for real, what I would do is probably make another state that's like states start or something like that equals 0 or something, and have that be the first thing. So, and here, you know, have it say when we start up, as soon as we start, print like press any key to start, and then check for keyboard input, any keyboard press, and that would transition us directly into playing, something like that, right? Other things that we could do is we could clean up some of the you know, quote unquote collision detection. So we could make it detect from the center rather than the corner, and that's not that hard mathematically to figure out, right? Next time we're going to be doing real collision detection, but not today, because that's a whole other thing. You know, also just like simple things like tuning for the amount, like 15 seconds is a nightmare. Like, that's impossible. And, you know, playing around with the amount of speed, right? Trying different amounts of bones, etc. Then, like, those are just, like, you know, off the cuff things that I would change or improve. Other things that you might want to do, though, is like, you know, we could make stuff move around on its own. We could, you know, make some of the bones run away from you if you want, or something like that. When you get closer, we could, you know, make, you know, a different type of bone, sort of like the UFO in Space Invaders, where like it spawns every certain amount of time, and then like just moves across the screen or something like that. We could do something like that. We're gonna be doing, like, I'm gonna explicitly show you how to do that specifically next time. So yeah, I'm just gonna let's just write down some ways to improve this game. Start state. Like menu. Like a win loss screen. Then, like, you know, the simple things like you don't really win yet once you get all of them. I'll quickly show you like how I would go about doing that, because like that gets into something that we haven't talked about that I don't expect you to figure out on your own. Really quickly, because running a little long on time. But you know, I did give myself an extra like 8 minutes or whatever because I was messing around with my camera, trying to get that to work. So yeah, like in update, wherever we are. This is right, yeah. We could say if, and then, so a lot of programming languages have some function of a data structure called like bones.length or something like that. Lua doesn't have that. Rather, there are a couple ways that we could check for length of something. The simplest way is just to use a hash symbol. So we could say bones equal to 0, then, oops, and then we could say, you know, cur state equals states.win, even though that doesn't really do anything yet. But like we can make it that then transition into some kind of win state or something like that. So yeah, make the player able to win. Then things like, so this is like easy changes. Intermediate changes are things like, should I go all the way across? Is that more aesthetically pleasing? I don't know. Let's say yes. Things like be able to reset the board after playing. So like a reset function. I'll put up here like, tweaking speed time builds. So yeah, like reset the board, right? Detecting distance from the center of objects. And then like, that is like moderately advanced. Not gonna put that quote changes. Things like, making objects move on their own. And then like, whatever, adding other mechanics we didn't talk about. So like up until like here, we've talked about basically like how to do all these things. But like, go wild. This is like, your thing. So oh yeah, also like reset the random seed. It's pretty easy. That's just like looking in the documentation. Could also say like adding art. That's also another like just look in the documentation. Not gonna talk about animation yet, but like, there are some ways that we can do animation without using external libraries also that we might talk about in the future. So yeah. Oh, one other kind of intermediate change is adding borders to the board. So like make you not able to go outside the bounds. So like that's not hard, it's just like a bit wordy, and you need to like think through the math a little bit, but it's not too wild, right? That's another one where like all the information is stuff that we've talked about so far. So anyways, this is like what I went a bit over, but that's fine. This has been me. This has been game development for everyone. This has been session 2. Thank you so much for joining me today. Y'all know where to get in contact with me. You can find me on Twitter at Synodai. My email is hyacinth@hyacinthmill.com. My DMs are usually open. There's still a Discord for this class. I haven't done much with it yet because like I haven't really had the time. But like maybe this week I'll put up like an actual, some posts and things like that. I posted the first 2 lectures in there also. So those exist on YouTube. It's going to be game dev for everyone. Like youtube.com/game dev for everyone is what I'm hoping for. But apparently I can't get a custom URL until I have 100 subscribers. So if you want, go over there, subscribe, have at it. If you, again, found anything in this lecture useful or enjoyable or whatever, or just want to like help me out a bit, you could drop me a few dollars at my coffee.com/hyacinth nil. Again, like passing a hat around at the end of the lecture. That's all I got for today. Thank you so much for I too love to code Vobigans. Thank you so much for joining me today, and there will be another one next week where we're going to dig into actual collision detection and like actual other entities that move around and stuff like that. We're gonna be basically making Space Invaders. You know what it is. Talk to you then, and if you want, go over to the Discord if you want to find the lectures. They're all gonna be archived on the YouTube and stuff like that. Subscribe to that, please, because like I would like to be able to get a custom URL. That's all. Talk to y'all next week. Bye.